Hey there, universe nerds. Today, we're chasing something we can't see, something enormous, mysterious, and powerful enough to pull entire galaxies toward it, including our own. It's called the Great Attractor, and it sits hundreds of millions of light years away, hidden behind the thick dust and gas of our Milky Way. We can't see it directly, but we can feel its gravitational pull. It's one of the biggest unsolved mysteries in cosmic structure, an invisible gravitational anomaly shaping the motion of the entire local universe. Let's start with the basics. When astronomers measure the motion of galaxies, they find that most are moving away from each other. That's the expansion of the universe, discovered by Edwin Hubble in 1929. But when scientists looked closer at the movement of our local group of galaxies, including the Milky Way and Andromeda, they noticed something strange. We're not just drifting with cosmic expansion, we're also moving sideways at incredible speed, about 600 kilometers per second, toward a specific region of the sky near the constellations Norma and Centaurus. Something massive is pulling us, but it's hidden behind the Milky Way's galactic plane. That mysterious gravitational tug became known as the Great Attractor. It's not a single object like a black hole or a galaxy, but a region of space packed with enormous concentrations of mass, galaxy clusters, superclusters, and dark matter. But because it lies behind the thick band of our galaxy, an area astronomers call the zone of avoidance, it's extremely difficult to observe directly. For decades, we could only infer its presence by watching how galaxies move around it, like leaves swirling toward a drain you can't see. By the 1980s, astronomers realized that the Great Attractor wasn't just pulling us, it was influencing thousands of galaxies across hundreds of millions of light years. The entire Laniakea supercluster, the vast cosmic structure that includes our Milky Way, is being drawn toward it. To visualize this, imagine the universe as a vast ocean of galaxies. The Great Attractor is like a deep current under the surface, pulling entire regions of that ocean in one direction. So what's actually there? With the help of infrared telescopes that can see through the Milky Way's dust, scientists have uncovered part of the answer. At the center of this gravitational sinkhole lies a massive cluster of galaxies called the Norma cluster, a Bell 3627, containing thousands of galaxies and trillions of stars. But that's not all. Beyond it lies an even greater structure, the Shapley supercluster, one of the largest known concentrations of galaxies in the observable universe. The Shapley region contains over 10,000 galaxies spanning 650 million light-years and might be the real heavyweight responsible for much of the pull we feel. It's mind-blowing when you realize that the entire Milky Way, the Andromeda Galaxy, and countless others are falling towards something we can't even see with the naked eye. Every second we move a little closer, not that we'll ever reach it. Cosmic expansion ensures that even as gravity pulls us inward, the space between superclusters continues to stretch. We're caught between two cosmic forces, gravity's attraction and dark energy's expansion, an endless tug-of-war that defines the universe's large-scale motion. The Great Attractor also reveals just how interconnected everything in the universe really is. We tend to think of galaxies as independent islands of stars floating in space, but in reality, they're part of vast cosmic rivers and filaments, gravitational highways connecting clusters and superclusters in a web-like pattern. The Great Attractor is one of the nodes in this cosmic web, a gravitational hub at the intersection of multiple filaments of galaxies. Its invisible presence helps map out the architecture of the universe itself. And yet, the deeper we look, the more mysterious it gets. Some astronomers suggest that what we call the Great Attractor isn't a single gravitational center at all, but the combined effect of multiple superclusters, Norma, Shapley, and others, all working together to shape the flow of galaxies. Others think dark matter plays a dominant role, since it makes up most of the universe's mass but emits no light. What we perceive as the Great Attractor might actually be the gravitational signature of an enormous dark matter overdensity, a cosmic mountain hidden beneath space's visible terrain. The most poetic thing about the Great Attractor is that we'll never see it as it truly is. It lies in a region obscured by dust and time, and by the time its light arrives us, billions of years will have passed. It's a reminder that even in an age of advanced telescopes, there are still parts of the universe we can only infer, not observe. We know it's there because of how everything else moves. It's the unseen hand shaping the cosmic dance. Invisible, but undeniable. So what is the Great Attractor? It's the gravitational ghost of the cosmos, the hidden mass that pulls us through space, guiding the motion of galaxies like a silent conductor. It's not just a mystery of astronomy, but a symbol of how little we still know about the forces that shape our universe. Every second, the Milky Way races toward it, not to reach the end, but to remind us that we're always in motion, forever drawn towards something greater, unseen, and beautifully unknown.